Good evening. So today's sum is 2.2.6. We have a ABC, a pointer with B being supported on a spring having stiffness K is equal to 800 kilonewton per meter. B is supported on spring here which have upward force of K delta. It is pinned at A. We have now on putting a load P at distance X, the C moves by 3 degrees. So we have to find out X distance. So taking sum of moment about A equals to 0. Now P is downward, so it is clockwise, so minus Px, plus F is upward, so it is plus anticlockwise. K delta B equals to 0. We get delta is equal to Px by Kb. Now the pointer angle moves by alpha 3 degrees Celsius. 3 degree. So tan alpha, that is tan 3 is equal to perpendicular by base, that is delta by B. So we get x tan alpha is equal to Px by Kb square. So x is equal to tan alpha Kb square by P. On solving we get x is equal to 118 mm. So the load should be placed at distance x is equal to 118 mm for 3 degree rotation. Now coming to 2.2.12. It has an ABCD bar supported on BE and CF steel bars which has modulus of elasticity is equal to 200 GPa. Now two axial loads are there on it, respectively P1 400 kilonewton, P2 360 kilonewton, and also given the cross section of BE is 1100 millimeter square and ACF is 9280 millimeter square. So we have to find delta N and delta D. Now here is the free body diagram. P1 and P2 downwards, FB and FCF upwards. So taking moment about B equals to 0, we get 400 and minus 400 into 1.5 plus FCF into 1.5 minus 360 into 0.6. So FCF is equal to 464 kilonewton. Now again taking moment about C, taking sum of moments about C, we get 403 minus FBC into 1.5 minus 360 into 2.1 equals to 0. So F on solving we get FB is equal to 296 kilonewton. Now this is the displacement diagram. Here is the displacement BE, CF, delta D and delta I. So we will have to find out shortening of bar. Now shortening of bar delta B is FBE into LBE divided by EA delta B. On substituting the values we get delta B is equal to 0.4 mm. Similarly, for shortening of bar CF, formula is delta CF is equal to FCF into LCP by EACP, and on substituting the values we get delta C is equal to 0.6 mm. Therefore, delta BE minus delta A is equal to delta CP minus delta BE, that is delta BE minus delta A, delta BE minus delta A is equal to delta CF minus delta BE. Hence we get delta A is equal to 2 delta BE minus delta CF, which gives us 0.2 mm downwards. Similarly, delta D minus delta CF, delta D minus delta CF is equal to 2.1 by 1.5 into delta CF minus delta BE. So delta D is equal to 2.1 by 1.5 delta CF plus delta CP minus 21 by 15 delta BE. On solving we get delta D is equal to 0.880 mm downward. Now coming to problem 2.3.6. In this there is a two-story building which has steel columns, AB in the first floor and BC in the second floor. This is the diagram. The load P1 at first floor is 400 kilonewton and at P2 is 720 kilonewton. Given the length of each column is 3.75 meters, cross-sectional area first floor is 1100 millimeter square, first floor is 1100 millimeter square, second floor is 3900 millimeter square. Now A is 206 GPa. We have to find out total shortening delta AC and how much additional P0 load can be applied if maximum shortening or delta AC is 4.0 mm. Number 1, shortening of delta AC of the two columns formula is sum of force into length by EA. So NAB into L by EAB plus NBC L by EABC. So 720 plus 400 kilonewton to 3.75 by 206 plus 11,000 plus 400 into 3.75 by 206 into 3900. So we get delta AC. So we get delta AC is equal to 3.72 millimeter. Now additional load at C. So delta naught is maximum minus delta AC, which is 0.2794 mm. Now delta AC is equal to P naught L by EAAB plus P naught L by EABC. So delta AC is equal to P naught L by EA to 1 by AAB by 1 EABC. So P naught is equal to E delta naught by L into AAB ABC by AAB plus ABC, and on solving we get P naught is equal to 44.2 kilonewton. Now coming to 2.3.4, there is a bar which has length B, thickness T and modulus of elasticity E. Slot has width B by 4. Now we have to find a formula for elongation D of the bar and also calculate elongation if it is made of high strength steel and length is 750 mm. Now we have to consider that the bar is divided into three parts. So this part is L by 4, this part is L by 2 and this part is again L by 4, which is shown here. Now the total strength delta L is equal to delta 1 plus delta 2 plus delta 3, which is the area, which is PL1 by EA2 plus PL2 by EA plus PL3 by EA3. Now L1 is equal to L3, which is L by 4, L2 is equal to L by 2. Cross-sectional area of A1 and A3 same, which is B into T, and A2 is equal to 2 pi by E by BT, which is 3 by 4 BT. Now putting all the values in delta L, we get delta L is equal to 7 by 6 PL by EBT. Now given L is equal to 750 mm, E is 210 GPa. Now the formula we took just a few seconds ago, delta L is 7 by 6 into PL by EBT. So sigma is P by delta 2 minus 160 MD. So P by BT is equal to 16 to 3 by 4 delta mint, which is 120. Now delta is equal to TLP by 6 EBT, which is 7 by 6 LE by 3 by 4 sigma, with coming out delta is equal to 0.5 mm, and we get our answer. Thank you.